Free audio post-production by alphonic.com.
Got one more Zach and I wanted to do this week, which is more of a study and reminder for ourselves. Design Guide 1. We'll talk about that more, I guess, the next 30 minutes or so. But to give you a heads up, we've got some episodes coming out as soon as I edit them about a really exciting software package. This is the space that most engineers use old Excel files, myself included. And then we're talking to a few people about AI because it's going to start changing our profession, and really it already has. But for now, let's dive in and refresh our memory on Design Guide 1.
The Structural Engineering Podcast.
Well, Max, another episode, just you and I this week, huh?
All right.
I think a cool topic to talk about and something that's important about keeping our buildings grounded, which is fairly important here, is AISC's Design Guide 1.
Yes.
Base plates and kind of everything that goes with that.
There was a line in the Design Guide 1, which I really enjoy, that framed this well, that is the last thing that we design and the first thing in the ground, besides foundation, that I think puts a good scale to this. Like, it's often when a project is in a rush, it's like, oh, we just make sure the base plates are fine and we use a generic. We don't think about it exactly. Should we think about it a little more? And just some things we need to think about is what we're going to talk about today.
Yeah, so let's throw out what the anatomy of a base connection looks like. So you have a column that's carrying a gravity load, maybe some shear, some moment, obviously the axial load from gravity. You have a base plate. We're just going to talk steel in this whole conversation, as this is AISC's design guide. You have steel anchor bolts that attach that into some sort of foundation. For today's discussion, we're just going to say the foundation is always made out of concrete. And then between that steel base plate and the foundation is going to be a gap in which is going to be filled with grout. That would be the traditional way that we would all think of a base plate and a connection of the building down to the foundation.
Do you know how many design guides AISC puts out? I don't know this number.
I bet it's 30 or more.
Yeah, I think number 1 and number 11. So I'm only the two that I have used the most.
I know there's a new one on rain loads and ponding, and I believe that's Design Guide 40.
Okay.
So at least 40.
And many of them are free if you're an AISC member. Yes, there are 40, and they're all free if you're a member. I might even put the link in the show notes just to flip through. This is what I read for entertainment at night, so enjoy. There's some really cool ones. Take a look at the link.
So one thing I wanted to get into this week was kind of going over what I find often that is useful to remember, to know, to realize that there's a quick table or calculation for designing these. And hopefully in a way that when we publish our quick cheat sheet for some of this on our website and LinkedIn, it'll kind of make sense and it'll speed up your efforts and accuracy in designing base plates. But before we get into that, I want to just throw out a quick little plug of our weekly trivia that we do.
Oh, yeah.
This week, Max, what did we send out?
Pulling questions right out of Design Guide 1. So it fits really well with the episode this week, and we got to see what questions might fit in there well and how people think about this.
One of the questions, just from an example standpoint, was, does Design Guide 1 recommend hooked anchors for tension forces or headed rods with nuts? Max, what was the answer?
What was my answer? Was the Design Guide 1 answer. Hooked rods are kind of problematic for higher tension forces. This was realized after these were being used, but the rod would just straighten when it had a lot of tension through it, so it wouldn't hold that bending shape. So an anchored rod is far better. Putting a plate on the bottom is not always necessary, unless you have a breakout. It's not really that important, but bent rod, I would avoid that one.
Well, look at our LinkedIn, Instagram, reach out to us if you'd like to sign up for the trivia. It goes out every single week with a few questions right into your inbox. It's kind of fun to send to your coworkers and other staff that you're working with just to stay up to speed and just to keep different, topics at the top of mind.
Yeah.
So back to what I said, I wanted to start off with some really simple things that are kind of on our cheat sheet that will kind of help things go a little quicker. So bolt edge distance, AISC 360 is where most all these references come from. And it's table J3.4, fairly common anchor bolt size. Max, what are you using for a typical couple story building?
I'm a big fan of a three-quarter diameter. Yeah.
What would you say you typically put as an edge distance from like best practices for that?
We got a little off path here, but that's what the delete button is for. Edge distance from center of standard hole to the edge of a connected part or the edge of the plate is only 1 inch for a 3/4 inch diameter bolt. But if we're looking at bolt spacing, we often use a 3D number, but really we can get that down to 2 2/3 diameter if needed.
Now, Max, the next thing here is bearing area design. So you're sitting this base plate onto concrete. You need to check the bearing area. What design code would you start with to check that?
That'd be the ACI.
Absolutely. So table 22.8.3.2 is nominal bearing strength based off of your area that you are being supported by. And then more or less it's the area and the strength of concrete that you would evaluate your load against.
How strong is that concrete allowed to be if you're just bearing on it?
Real strong.
What fraction of the strength?
85%.
Good number.
So the next one, something that's more in maybe the concrete side of things, is the cover of the rebar and the anchor bolt. And where would you find that? What code?
ACI?
Yeah.
I like these questions having the same answer. I'm really good at that.
This is amazing so far. So table 20.6.1.3.1 is specified concrete cover for cast in place concrete members. So what would you say the specified cover is for something cast against the contact and in contact with the ground?
I think that's 3.
Okay. Yeah, absolutely.
Okay.
What about something that is exposed to weather or in contact with ground that is a number 6 through a number 18 bar?
That one's only 2.
Yeah, exactly. So this is a great chart to use, and you can use these values as well when looking at where your anchor rods or your anchor bolts should sit with, trying to both stay probably within the cage of your pilaster, your reinforcing, but just something to think through to make sure you have enough cover.
I like it.
So, Max, what if you need to develop significant tension loads from your anchor? What would you do?
Make the building a lot heavier.
There you go. Totally ignored tension. Fantastic idea. But let's say you can't do that.
Oh, I mean, there's so many. Maybe you're doing a splice to the rebar of the foundation.
What about developing the length of the rod over your vertical bar in your foundation or in your pilaster to develop the load out of the anchor and into the reinforcing?
Yeah, I assume breakout won't quite get you there. So if you develop this, you can just rely on the steel strength of the reinforcing.
Yeah, exactly. And so you figure out how long your anchor bolt needs to be and how close to that vertical bar. And then it's more or less development length between those two. Not exactly, but fairly close. Again, your anchor bolt strength and your rebar strength are going to be a little bit different grades of steel that we're utilizing. Now, let's stop on that. Let's talk about some common material specifications. So for a base plate of let's say a tallish size building, what grade of steel might you use?
I'm only 36.
Okay. We found that, and in Design Guide 1, it actually suggests today with our stronger grades of steel that you use ASTM A572 grade 50, where Design Guide 1 second edition said 36.
Yeah, so this is updating, and I know that the general notes of where I'm currently working, we specify 36 for base plates, but many steel suppliers are able to give grade 50 base plates, grade 50 plate steel for everything. And so that is in the category of 36. So they're able to just swap this out. But that is what is provided most of the time. And we're almost at the point that we just specify this and they give 50 KSI. So even like occasion we'll say 36, but it's not really what's happening.
So a pretty common one, again, specified in Design Guide 1, would be anchor bolt grade, and that's ASTM F1554 grade 36. Now, one question I have for you, Max, is what's the most common grade for washer plates?
Oh, I don't know.
ASTM F844.
Oh, yeah.
Got you there.
Yeah.
Got you there.
Wait. There was a little jump on the question asked. The washer ASTM is here to specify some properties and provide a consistent product for its purpose. But in this case, the purpose isn't structural, and this ASTM does not specify a minimum yield strength, only that it cannot be hardened steel. For plate washers, transferring any load, make sure to specify if this is A36 steel or grade 50.
Okay, as we continue going through this, let's say our column is a wide flange. What steel specification do wide flanges come in?
A992.
What about an HSS column?
A500, grade C.
Yeah, absolutely. So 50 KSI steel, both in the wide flange now and in the HSS.
Which is also an update for older folk like me. Like that was 46 not that long ago.
Yeah, absolutely.
Last edition.
Now, Max, let's say your foundation concrete was specified at 4,000 PSI. What strength of grout would you utilize underneath your base plate between that and your foundation?
Ooh, so I would like a minimum of 8,000 in that case, and AISC Design Guide 1 has a very similar minimum. They'd like to see double of your concrete strength for grout.
Yeah, absolutely. So a minimum of 8,000 PSI would be suggested for that design. So Max, the other thing would be a minimum concrete strength based on our exposure classes. This is a table within ACI 318.14 for just our reference here, which is 19.3.2.1.
How low can we go?
That's a great question. In this table, based on our exposures, we can go down to 2,500 PSI concrete, which is probably pretty low for what you're typically getting for a building. So just looking at the table, something that I think is interesting to point out is there's multiple spots within it that are 2,500. There's one spot of 3,500, multiple levels that would get you to 4,000 to 4,500, and then two grades of our exposure classifications that would get you to 5,000. So if you're just thinking about your foundations, just minimum from exposure classifications, you're looking at 2,500 to 5,000. And then there's also additional requirements for air content, cementitious materials, and then maximum water soluble chloride ions content in your concrete. Just this whole thing is about exposure to different materials. It could be moisture, it could be many different things.
What is the most common strength that you're using in projects?
I think I find myself mostly using 4,500, and it seems to be fairly readily available at most projects across the country. It seems like once we want to get into the 5,000s, it becomes a little bit more challenging and significantly more money. And so what I've seen and found is it's more the vertical construction of the shear walls and things like that that use a little bit higher strength.
Yeah, and I think this is not what the episode is about, but lightweight falls in that same category of if you'd like to give this a try, it's not available everywhere, so be sure that you're specifying something that they can get for this project. Wait, I want to mention concrete strength a little more. Whether you want to reduce embodied carbon of the full structure or even just reduce the cost, high strength generally takes more cement. Cement is problematic. We can use SCMs to get there, but even that is limited in most specs. Providing an excessively strong concrete is poor engineering, and I don't want to do it. But on the other side, requiring column pilasters be different than the foundation doesn't make any sense. So think about the strength that is needed and the sequence of concrete pours, rather than something in the general notes that is never touched. We balance cost, speed, material availability, construction practices, all from a desk far from the construction site. But this doesn't mean we shouldn't have a reason for every decision.
So something I found that's interesting that many may know or may not know is that in ACI, they specify shear reinforcement and pilasters. So I think I'll just read the section directly out of there because I think it's the best way to put it. So this is section 10.7.6.1.6. What a mouthful. If anchor bolts are placed in the top of a column or pedestal, the bolts shall be enclosed by transverse reinforcement that also surrounds at least 4 longitudinal bars within the column or pedestal. The transverse reinforcement, or our shear reinforcement, shall be distributed within the top 5 inches of the column or pedestal and shall consist of at least 2 number 4s or 3 number 3s. And that is a minimum in the code.
Yeah, this is one that really sticks in my head because I've reviewed some drawings from younger engineers that have not exactly had this rebar spacing at the top of the column. And you have to keep in mind, this is a codified element, and you should make sure that you have this 3 number 3s or 4 number 2s. What the?
You should have a stroke.
3 number 3s or 2 number 4s in the top 5 inches. Do you, Zach, play that as the top 5 inches, it has to be in that, or is that center line of the bottom bar?
That's a great question.
It is not. I've looked into what they're trying to specify, and I have not found anything that is very clear. And I've seen both versions, and I've approved either. Like, I think they're both in the category of okay.
Yeah, I mean, it's not going to be off by much. Something I think is interesting is just thinking through, like, if you're going to provide a cover, of course, on top of your pedestal, 1.5, maybe 2 inches that occurs there. Now you have those bars only within the top 3 inches or within 3 inches, those bars. So they become very close together. So, I can imagine just a little bit more spacing could be beneficial.
Yeah.
But I think most ways that this is specified is just stating to the contractor, the rebar installer, I guess, that you just need to provide this within the top 5 inches and kind of allow them to figure that out a little bit more. But I think when our loads are significant and this really matters, there's more calculation that goes into it. This is somewhat a CYA, I would say. That's like best practices. Hey, you should have something there to make sure the top of this column is going to be sufficient. It's also, having some ties within the concrete column element where you have all this load coming in is going to be beneficial as those bursting bars, maybe.
Yeah, I almost lean at this as partly constructability, and then the moments that you'll see at the base of the column when you're putting this thing together will first pry at the top rebar, like whether it's a shear or a moment, like that will see the force first while this building is being constructed.
So the next one on here is concrete pilasters. Although this is not Design Guide 1 necessarily, I think it's something that is just interesting to know. So for columns with cross sections larger than required by considerations for loading, which is fairly common, of which most engineers do, they're bigger for the geometry of the base plate and things, shall be permitted to base gross area considered required reinforcement and design strength on a reduced effective area not less than 1/2 the total area.
I've heard about this one. I don't think used it.
You can reduce your reinforcing in your pilasters because it's oversized and you're not providing let's say, typical 1% of steel, but maybe 0.5% of steel. And that's a reference within ACI. The next piece is just design your base plate. AISC Design Guide 1 has the equations and goes through really well, but it just helps with transferring those loads as we discussed, such as axial, shear, and our moments. And maybe, the base plate is taking loads from a brace frame, moment frame. There's so many different applications that we could go through. Max, we already touched on it a little bit, but just to reiterate, it's recommended that grout have a design compressive strength at least twice the strength of the foundation concrete. And that is within Design Guide 1 as just a recommendation. The next piece is your base plate weld. It's really designed for the load of which is going through. There's varying types of forces going on your column, so a lot of different welds that could occur, but fillet welds are often preferred for their efficiency and strength, especially for tension resisting conditions. Sometimes let's say you have a big wide flange, you got to develop those flanges in your base plate. You're probably CJPing those in and not necessarily doing fillet welds. That would be significant.
Unless it's a gravity only, right? And then you can get by with just the fillet welds. And I really like the commentary that they have here that don't just do a 1/4 inch all around on a wide flange. Think that the K region, it doesn't really benefit you to weld this, and it can be a negative. Even the web is not exactly that helpful, but many cases, just the flanges, top and bottom of your beam is plenty to handle the forces that are placed on this.
So for just 1 second, going back to grout design, do you know what the preferred layout of the grout is? So once you place it...
Under the base plate is ideal.
Wow, that is correct. Okay. Under the base plate.
Yeah.
But what shape should the edges of the grout form?
God, I only have bad answers. Rectangles. Okay, yes. So
what's preferred?
So preferred is a 2-to-1 slope or something. I forget the slope. A slope away from the base plate.
What is something that would be satisfactory, but not preferred necessarily?
Vertical works, but it's not their preferred.
Okay. What about unsatisfactory? There's 2 scenarios here.
Oh, so if you have the grout coming up over the base plate, that is not good. If you are negative slope, so if it goes in towards the foundation, that one is clearly not good. But that I don't even know if they categorize that because that one is so silly. To do a rectangle outside of the rectangle of the base plate, that one is not great. And the other one, I think that's it.
Yeah, exactly. Okay, the next one I wanted to bring up and the last one is anchor rod holes and washer design. So anchor rod hole sizes are critical for accommodating the tolerances within construction, right? Anchor bolts aren't placed perfectly, so the holes need to be a little bit bigger. So with AISC's recommended dimensions are provided in Design Guide 1 and Table 4.3. Those ensure compliance with OSHA guidelines and minimize field issues. Washers Why would you typically use a washer, Max, on, let's say, a higher seismic project where maybe there's some different load going through this base plate?
Maybe there's some moment that transfers down here, so you have a tension force that needs to get to your anchor bolts, or clearly just a shear force if it's a lateral system.
Yeah, exactly. So often the holes are fairly large in a base plate versus other things we're dealing with. So if you're dealing with shear, that base plate's going to move until it engages those anchor bolts. If we're just idealizing everything, I get base plates are usually covered in concrete everywhere, but we don't look at that as part of the shear too often. So if you're utilizing fairly large openings in your base plate, you want to weld a washer over it so that you have less movement of your base plate when you're calculating drift and shifting of the building. So it's better load path. You don't have to crack or deform anything else to get the load actually in. So washers, often custom fabricated, must completely cover holes to avoid structural problems, and their design varies based on anchor rod needs, such as resisting tension, as you mentioned, or moment forces. Using smaller hole diameters will potentially cost savings is generally discouraged due to the placement tolerance issues that could be created in the field with misplaced anchor bolts. Something I always think through when I'm designing is who's installing what. Who's placing who's placing the anchor bolts, and then who's coming behind and placing the concrete, right? The concrete crew doesn't it's not important to them that the anchor bolts are exactly placed well, where the steel crew really needs those anchor bolts and wants those anchor bolts placed well. And something I find on almost every single project is someone drives over an anchor bolt or many anchor bolts, and it seems like the protection of those anchor bolts become quite a struggle for the general contractor. So Design Guide 1 also gives guidance on when can you bend the bolt back and different ways to fix that. Do you chip it out and use splice or couple it?
I think it also gives guidelines on the angle that you're allowed to bend back and how many times you're allowed to bend the bar.
Yeah, it sure does.
How many times?
Once. It's just like rebar. The ACI says you can bend it once.
Yeah.
In the field.
Yep.
Okay, so going back to our recommended sizes for washers and anchor bolt holes and base plates. So there's a little bit different recommendations based on the grade of your anchor bolt. So ASTM F1554, grade 36, 55, and 105. And so there's a little bit different recommendations on the washer plate thickness and the bolt hole. So Max, going to our typical grade 36, as we discussed, an anchor rod diameter of 3/4 of an inch. The base plate hole diameter would be what?
Oh, I think 1 5/16.
Yeah, exactly. What would you say the minimum washer width would be?
I think it's 3/4.
It's 2 inches.
Oh, the width. Sorry, I was thinking of thickness.
And then the minimum washer thickness for a 3/4 inch anchor rod.
Yeah, and I'm way off. I think at 1/4.
Yeah, exactly. So if we get up to a 2-inch anchor rod, so significantly larger of an anchor rod, how big is the base plate hole diameter?
Oh gosh, a little over 3-inch.
Yeah, 3 1/4. And then the minimum washer is 5 inches with a thickness of 3/4 inch.
There we go. There's my 3/4 that I wanted.
Exactly. So as we move up in strength, we start seeing a lot thicker washers being utilized for that. And then the other piece of this, as we kind of discussed, this is recommending using washers, for a couple different reasons. But then maybe when you want to make sure you have less movement in your base plate, you'd weld these washers to the base plate.
Can I ask how many anchor bolts you're using? And I've seen 4 all the time, but why are we doing 4?
Because of OSHA.
That makes it sound like you're mad at OSHA, but keep going.
Yeah. No, OSHA, you're great. OSHA requires that because if you would have done the quiz this week, Max, you would have learned that OSHA requires a 300-pound point load 18 inches away from your face of your column, which an unsupported column, that would create moment and fixity at the base. And they've determined a 4-bolt anchor for a main building column, not a post, but a main building column, is a safer condition, where if you have posts that have less loads on them, they're acceptable with less anchorage.
I like the posts that they give you a weight for the weight of the column. I don't use the word column, When your column is actually a post, they specify how heavy that is. And if it's under some weight, it's just a post. Do you remember what that weight is, Zach?
300 pounds.
That's it.
Now, I've heard of people, and maybe it's in OSHA, and I don't want to be quoted on this, that maybe there's a condition where you can't use 4 anchor bolts, and there is ways potentially around that with shoring up the column or other means that might be able to get you there, because we have often very interesting shaped buildings that can't always accommodate exactly a 4-bolt anchor pattern. So Max and I are just kind of talking about the high level things within this episode. And if you're looking for actual answers and details for your own project, definitely recommend going to OSHA to read those standards yourself, as well as Design Guide 1 and ACI. So Max, that's kind of the cheat sheet that we've created for everyone. And I found it to be fairly helpful in describing how a base plate goes together, a base connection of a column to the foundation. What have we missed? What else do you want to talk about?
There's a couple small details, but they're not exactly design details. You need to have them in the details that you provide, but they are not going to reflect the calculations that you do. I'm thinking about the grout space, right? How much, when you set your base plate, how high above the concrete should this be? And this changes. They give you a range either way, but this changes on finished concrete, or if this is a rough concrete, sort of the top of a foundation, you have a different scale. Do you know what it is, Zach, for above a foundation?
I believe it's 1.5 inches.
It can get up a little bit higher, though. What's the cap?
2 inches.
Yeah, of course, this is their recommendation. It can go bigger, but they have a 1.5 to 2 inch scale for a rough concrete. And if you're over a finished floor, which is going to be much smoother, they give you just a 1 number. What do you think that one is? It's less, so it's easy to guess.
It's 1 inch.
Yeah, 1 inch for that one.
Something I've always thought that's very interesting with grout space. And, if you drive around, you look at our infrastructure, our lights that go across our intersections, they usually have ungrouted base plates. Not always, but sometimes, if not most of the time. And they have a nut on top and below, and it's kind of held there. And I always think about the unbraced length of the anchor. And I think about this sometimes too from like the buildings we design. There's not a lot of guidance, and maybe there is an AISC Design Guide 1, and I guess it's not really a design guide for the construction group. It's really for engineers, but who tells the construction team when to grout the base plates? Is it best practices for them? Is it just knowledge from an issue they've ran into? I once was talking to a contractor, a steel fabricator actually, that fabbed up the steel for a football stadium. And all of a sudden, one of their columns dropped with a very loud noise. And what had happened is they had shim packs underneath the center of that column. And the column had something close to, I believe, like 1,000 kips on it, just dead weight.
Pushing it, yeah.
It shoved the shim packs into the concrete foundation below. It had so much load on. So I always think, like, say, take a typical 10-story building. At what point do the anchors fail without grout as they build that structure? Who's making sure it's getting grouted? It's probably not a catastrophic failure, but man, what a challenge if you drop that.
I think from my memory, that is often in design documents that they can only go in the specifications, that they can only go a few stories up before they need to grout. I don't know what that number was at the places that I've worked, but it is asking that there be grout placed at about 3 stories.
Yeah, that makes a lot of sense. I at one point, if I remember correctly, again, don't quote me on this, but there's a big push with the Euro code to where you designed your anchor bolts to some level to not have grout there, and that you'd have to design for some level of bending. Maybe that's induced from a shear load or something. But it's interesting that, as engineers, we're designing the final conditions, but there's so many different pieces that are important that occur at the right time when we're in construction.
Yeah, there is an AISC standard of erection book. I think I'm messing up the name of this exactly, but it has great sections. I think it's 100 pages, 3 online, and it just talks about how these things, how erection tolerances are built into the project, and what you need to make sure is clear in your documents so that the building can be erected easily and safely.
If you jump into Design Guide 1, you'll see there's so many more topics and complexities than Max and I have gone over and discussed. There's different design methodologies of your anchor bolts. When you get into high seismic, do you let them yield? Are they ductile? Are they not? How does that develop the loads? Also, at certain points when the loads become really high, especially in shear and fixities or a fixed base, how do you develop those loads when they're really ginormous? Both AISC 341, the seismic manual, has some suggested connections for shear and moment, but those are also, there's similar ones here in Design Guide 1.
Heck yeah.
So Max, what would you say you learned the most today talking about base plates?
I like Design Guide 1. This one has been in my head for a very long time, and I think it's the first one I read after school. I had a reason to flip through. And I think it really is, we use base plates in every steel project. It's so common, and it's nice to have some familiarity with it. So that is my biggest takeaway. What do you have?
I think in my career, it's what I've learned the most about base plates is just the fit up. What size holes need to go in it, and how do you provide the most fit up while keeping the building stable? Having holes that are 5 times larger than the anchor rod probably really nice for the field, but that's not great for what we're doing. So
yeah,
I think through my career, that's what I've learned the most is how can we provide the most tolerance to the field so it's constructible, but still creates stability in our structures. And thank you for listening to this week's episode of the Structural Engineering Podcast. We hope you learned a lot about Design Guide 1 and base plates and base connections. If you have any questions, feel free to reach out to Max or I via our email, and that's in the show notes, our Instagram page, our LinkedIn. We're very active on all of those and responsive. And if you have anything you want to share about your experience with base plates, anchors, anything like that, actually anything within structural engineering, reach out to Max and I.
Free audio post-production by alphonic.com.